Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to Math Solver. Today we are solving real world problem related to trigonometry and bearing in exercise 6.3 from cantab grade 9. Now in this video we will tackle a real world problem related to trigonometric identities. We will solve these problems step by step in a very easy and simple way. Let's get started. Now this is exercise 6.4. Problem number 1 is a solar panel efficiency is modeled as E is equal to E maximum cos square theta, where E maximum is the maximum efficiency and theta is the angle of the sun above the horizon. Rewrite E in terms of tan theta. You have given E is equal to E maximum cos square theta. You have to write this equation in terms of tan theta. Now let's get started. Now question number 1. Given efficiency equation is, you will write the given efficiency equation is E is equal to E maximum cos square theta. Now you have to express cos square theta in terms of tan square theta. For this purpose we will use identity that is 1 plus tan square theta is equal to secant square theta. We will prove this as 1 plus sin square theta over cos square theta. It will become, by taking LCM, cos square theta plus sin square theta. So cos square theta plus sin square theta is equal to 1. So 1 over cos square theta, which is equal to secant square theta. And we also know that secant square theta is the reciprocal of 1 over cos square theta. So we will make this as cos square theta is equal to 1 over secant square theta, and by substituting this value cos square theta is equal to 1 over 1 plus tan square theta. So we will write here the given equation in terms of tan square theta is E is equal to E maximum into 1 over 1 plus tan square theta. So this is the solution of this question. Now we will start question number 2. Now in question number 2, the amplitude A of sound wave from a moving source is A is equal to A maximum sin square theta, where A maximum is the maximum amplitude and theta is the observer's angle relative to the source motion direction. Express A in terms of cos theta. In this question, you have given A is equal to A maximum sine square theta and you have to express this as in terms of cos theta. Now we will start question number 2. First of all, you will write the given sound equation is A is equal to A maximum sine square theta. You have to write this in terms of cos theta. So, you know that sine square theta plus cos square theta is equal to 1. So, sine square theta is equal to 1 minus cos square theta. And then sine theta is equal to square root of 1 minus cos square theta. So, you will write in term of cos theta as A is equal to A maximum sine square theta will be equal to square root of 1 minus cos square theta. So, this is the solution of this question. Now, we will start question number 3. Now, in question number 3, you have a light ray enters a medium creating a reflection and refraction angle. If the reflection angle is theta and the refraction angle is phi and they are reflected by sine theta which is equal to k, sine phi where k is constant, use trigonometric identities to find a relationship between cos theta and cos phi. Now in this question you have sine theta is equal to k sine phi and you have to convert sine theta in cos theta and sine phi in cos phi to make a relationship between these equations in terms of trigonometric identities. Now we will start. Now in question number 3, the given equation between sine theta and sine phi which is equal to sine theta is equal to k sine phi. You have to convert this relation in terms of cos theta. So first of all you will write sine square theta plus cos square theta is equal to 1. Now you will find the value of sine square theta which is equal to 1 minus cos square theta. Now sine theta is equal to square root of 1 minus cos square theta. Now you will substitute this value here for sine theta and also for sine phi. If the angle is sine phi, just you will replace theta with sine phi. So sine theta is equal to 1 minus cos square theta k sine phi will be equal to square root of 1 minus cos square phi. Now we will take square root on both sides. Taking square root on both sides. So you will have 1 minus cos square theta is equal to k square into 1 minus cos square phi. Now this square root will be cancelled by this square. So you will get 1 minus cos square phi theta is equal to k square minus k square cos square phi. So in the next step you have to find the value of cos square theta. So you will write cos square theta is equal to 1 minus k square plus k square cos square phi. Now cos square theta is equal to 1 minus, we will take k square as common. Then we have 1 minus cos square phi. So now we will take the square root on both sides. Square root on both sides will become cos of theta is equal to square root of plus minus 1 minus k square into 1 minus cos square phi. So cos theta will be equal to this 1 minus k square into 1 minus cos square phi. So this is the final answer. We have changed the sin square theta, which was equal to the sin phi. So we get cos theta is equal to plus minus square root of 1 minus k square into 1 minus cos square phi. Now we will solve question number 4. Now in question number 4, the signal strength S from a geostationary satellite to a ground receiver modeled as S is equal to S maximum cosecant square theta, where theta is the satellite's angle above the horizon. Express S in terms of sin theta. Now we will solve this question. Question number 4. The given equation is S is equal to S maximum cosecant square theta. You have to convert this equation in terms of sin theta. So you will write this as sin theta is the reciprocal of cosecant theta. So you will write this as cosecant theta is equal to 1 over sine of theta, and cosecant square theta will be equal to 1 over sine square theta. So you will write this as, in terms of sine square theta, S is equal to S maximum cosecant square theta will be equal to 1 over sine square theta. So S is equal to S maximum by sine square theta. So this is the answer of this question. Now we will solve question number 5. In question number 5, we have a pendulum swing duration t at a small angle theta can be as t is equal to t maximum cos square theta minus 1, where t maximum is the maximum duration. Rewrite t in terms of sine theta. We have equation t is equal to t maximum cos square theta minus 1. We will write this as in terms of sine theta. Now the question number 5, that is equal to t is equal to t maximum cos square theta minus 1. You have to convert this equation in terms of sine theta. So first of all, we know that cos square theta plus sine square theta is equal to 1. So cos square theta minus 1 will become equal to minus sine square theta. You will substitute this value here. T is equal to t maximum. Cos square theta will be minus 1 will become minus sine square theta. So you will write as t is equal to minus t maximum sine square theta. So this is the relation in terms of sine theta. Now we will solve question number 6. Now in question number 6, an engineer is adjusting a satellite dish angle, the angle of reception theta and the angle and the signal deflection angle alpha are related by the equation cos theta is equal to m cos alpha, where m is constant. Find a relation between sin theta and sin alpha. Now we will solve this question. Question number 6. The given equation is cos of theta is equal to m cos alpha. So you have to write this equation in terms of sin theta. You will use the identity, that is cos square theta plus sin square theta is equal to 1. So cos theta is equal to 1 minus sin square theta. So in the next step, you will substitute this value in this equation to get this equation in terms of sin theta. So you will write, first of all, cos theta is equal to m cos alpha. You will take the square on both sides. It will become cos square theta, which is equal to m is a constant, so you can write m square and cos square alpha. Now cos square theta is equal to 1 minus sin square theta. and m square cos square alpha is equal to 1 minus sin square alpha. Now you have to find the value of sin theta. For this purpose you will write this as sin theta is equal to 1 minus m square into 1 minus sin square alpha. So you will get 1 minus m square plus m square sin square alpha. So we have to find the value of sin theta. For this purpose we will take square root on both sides, sin square theta, and this will become 1 minus m square plus m square sin square alpha. So sin theta will be equal to plus minus square root of 1 minus m square plus m square sin square alpha. So this is the solution of this question. Now we will solve question. Now question number 7 is, here a beam of light reflects as is enter water, creating an incidence angle delta and a refraction angle epsilon. The relation between these angles is given by cot delta, which is equal to p cot epsilon, where p is constant. Establish a relation between cot delta and cosecant epsilon. Now we will solve this question. Question number 7. Given that cot delta is equal to p cot epsilon, you have to convert this in cosecant delta and cosecant epsilon. Now you will take, first of all, take square on both sides. It will become cot square delta, which is equal to p cot square epsilon. Now you know that cot square delta is equal to cosecant square delta minus 1. So you will substitute this value here as cosecant square delta minus 1 is equal to p into cosecant square epsilon minus 1. Now you have to find the value of cosecant delta. For this purpose, cosecant square delta is equal to 1 plus p into cosecant square epsilon minus 1. Now you will take square root on both sides. Cosecant square delta is equal to square root of 1 plus p into cosecant square epsilon minus 1. So this will become cosecant delta is equal to plus minus square root of 1 plus p into cosecant square epsilon minus 1. So this is the answer of this question. Now we will solve question number 8. Now in question number 8, a concert hall, the angle beta of sound wave reflection of a wall and the angle gamma of the wave entering a microphone are related by tan beta is equal to n tan gamma, where n is constant. Drive a relation between secant beta and secant gamma. Now we will solve this question. Question number 8. you have the relation tan beta is equal to n tan gamma. So first of all, you will take the square. Tan square beta is equal to n tan square gamma. Now you know that tan square beta is equal to 1 minus secant square beta minus 1. You have to convert this in secant. So tan square beta will become equal to secant square beta minus 1, which is equal to n square. Tan square gamma will become equal to secant square gamma minus 1. So secant square beta will equal to 1 plus n square secant square gamma minus 1. So you will have secant beta is equal to square root of plus minus square root of 1 plus n square into secant square gamma minus 1. So this is the answer of this question. Now we will solve question number 9. In question number 9, a wind turbine blade efficiency B is modeled as B is equal to B maximum sin theta square root of 1 plus tan square theta, where B maximum is the maximum efficiency and theta is the angle of wind. Rewrite B in terms of tan theta. You will have to convert this equation in tan theta. Now we will start question number 9. B is equal to B maximum sin theta square root of 1 plus tan square theta. You have to convert this in tan theta. So you know that 1 plus tan square theta is equal to 1 plus tan square theta is equal to secant square theta. So you will write B is equal to B maximum sin theta is equal to into 1 plus tan square theta by taking square root on both sides. This will become secant theta. So B maximum sin theta, and secant theta is the reciprocal of 1 over cos of theta. So B is equal to B maximum sin theta over cos of theta. So sin theta over cos of theta will become tan theta. So we have write this equation in terms of tan theta. Now we will solve question number 10. In question number 10, you have an optical experiment. The intensity I of light beam passing through a polarizing filter is given by the equation I is equal to I maximum sin x tan x plus cos x, where I maximum is the maximum intensity and x is the angle of polarization. Express the intensity in terms of secant x. You have to convert the given equation in terms of secant x. Now we will start this. Given that I is equal to I maximum sin of x tan of x plus cos of x. Now you have to convert this in terms of secant x. So first of all, you will substitute the value of tan of x. I maximum sin of x into tan x is equal to sin x by cos x plus cos x. So it will become sin square x by cos of x plus cos of x. Now we will take the LCM of this. By taking LCM, we have sin square x plus cos square x and cos of x. So this will become I maximum sin square x plus cos square x is equal to 1. So 1 over cos of x. So cos is the reciprocal of secant x. So I is equal to I maximum secant x. So this is the solution of this question. Now we will solve last question of this exercise, that is question number 11. Now in question number 11, the range R of a projectile launched at an angle theta with the horizontal can be modeled by R is equal to V square sine 2 theta by G, where V is the launch speed and G is the acceleration due to gravity. Using trigonometric identities, convert this model to find the projection range for launch angle theta is equal to 15 degree, 30 degree, 45 degree and 60 degree. Now we will solve this question. Now before starting this question, I will share a trick how to learn trigonometric ratios. First of all, write numbers as 0, 1, 2, 3 and 4. Divide all these numbers by 4. So 0 by 4, 1 by 4, 2 by 4, 3 by 4 and 4 by 4. So 0 by 4 is 0, 1 by 4 is 1 by 4, 1 by 4 is 2 by 4 is equal to 1 by 2, 3 by 4 and 1. Now you have to take square on all these terms. It will become 0, 1 by square root of 2, 1 by 2. This is equal to 1 by 2 and 1 by square root of 2, square root of 3 by 2 and 1. Now reverse all these values 0, square root 3 by 2, 1 by square root of 2, 1 by 2, 0. Now divide these values. You will have 0 by 0, 0. 0 by 1 will become 0 and 1 by 2 divided by square root 3 by 2 will gives you 1 by square root of 3. 1 by square root of 3. 1 by square root of 2 divided by 1 by square root of 2 will become 1. This is equal to square root 3 and 1 by 0 is undefined. Now these are the values of at 0 degree. These are values at 30 degree. These are values are equal to 45 degree. These are at 60 degree and these are at 90 degree. So we have find these three values. So this is the value of sin theta, this is the value of cos of theta and this is the value of tan of theta. Now by remembering this table, you will easily find the value of 30 degree, 45 degree, 60 degree or 90 degree. Now we will use this. Question number 11. You have R is equal to V square sine 2 theta by G. So first of all, at theta is equal to 15 degree. R is equal to V square sine 2 into 15 by G. So this is equal to V square sine 30 by G. So by table we have sine 30 is equal to 1 by 2. So this is equal to V square 1 by 2 by G. So we have R is equal to V square by 2G. So this is the value at theta is equal to 15 degree. Now we will find at 30 degree. So at theta is equal to 30 degree, R is equal to V square sine 2 into 30 will become sine 60 degree by G. Now V square sine 60 degree is equal to square root of 3 by 2. So at 30 degree its value is V square square root 3 by 2G. Now we will solve the value at 45 degree. R is equal to V square sine 45 degree will become 2 into 45 by G. V square sine 90 degree by G. So sine 90 degree by G, at sine 90 degree we have the value 1. So V square by G. This is the answer. Now at theta is equal to 60 degree, R is equal to V square sine 2 into theta means 2 into 60 will become sine 120 degree by G. So at 120 degree we have the value of this V square by G square root of 3 by 2. So this is equal to V square square root of 3 by 2G. So this is the solution of this question. If you understand all the question of this exercise, please subscribe Math Solver 1117 and also share the videos in all student groups so that you can easily solve the problems related to trigonometric identities. In the next video, I will solve the next exercise of this chapter. Stay tuned to Math Solver 1117. Allah Hafiz.